So hello everyone, let's talk about this question, delete node in BST. So the problem description goes as, given a root node reference of a BST and a key, delete the node with the given key in the BST, return the root node reference possibly updated of the BST. Okay, so what what we have to do? So let's go to the whiteboard. So yeah, let's see. So first of all, we have to delete a BST. So let's make BST, which is similar to question 5. So, so first of all, we see that this is a binary search tree, valid binary search tree, we can say. Okay, what happened? So we have to basically delete a node. In question, we have given, yeah, we have to delete a node 3. Okay. So how to delete a node? Basically, we can make this left child will be the new node, maybe this child. Okay, so while deleting a node we have to take care of our BST also. Okay, so basically while deleting a node we have to take care of BST also. So there are basically three cases for that. So let's talk about case number one. Suppose case number one. Let's rub this. Okay, so let's talk about case number one. So in case number one, which is a easy case, suppose the node the node which we have to delete is a leaf node. Okay, is basically a leaf node. Okay, basically a leaf node. So in that case, suppose in this tree we have we have to delete we have to delete node number 2. So we can easily put uh, basically this is our root at that case, current root. So we can set our current root left child will be equal to null. So basically we can put current root left left will be equal to null. Simple. Okay, so this is the case one in which if we have to delete a leaf node we can simply return null value to its current root node. Okay, now another case, basically if we have let's talk about case number 2. So in case number 2 what we have given, suppose we have to delete a node which is having one child. Okay, which is having a child whether it is left or right. The node deleted is having either left child or right child right child. Okay, so let's talk about this case. Suppose we have to delete a node, let's say node number 6. We have to delete node number 6. So in that case what we have to do? So in that case we can simply do we can simply do if first of all we have to check whether it has a left child or right child. So as we can see here there is no left child for this current root. See your current root. Okay, so there is no left child, so we can basically make suppose this what we can say, suppose our root node is connected to our current node as a right child. Okay, right child. So basically we bypass this and connect it to the current root right. Okay, so simply basically if our root node is present, root node right will be equal to our let me rub this, will be equal to our current right, current root right. Okay, simple. In case of there is no left child. Okay, suppose this is the same case. Let's talk about same case. Suppose here is number, let's suppose let's talk about 5.5, so which is basically smaller, so it does not have any difference. So suppose we have to delete 6 again. Now here is the case, there is a no right child, so we simply make our current root right will be our current left. Okay, simple. In the case where we does not have any right value of the current root, so this is the second case. Let's talk about another case. Let me rub this. Suppose, let me, yep, suppose, suppose let's talk about the case third. Suppose we have to delete a node which have both left and right, left and right child. So in that case, what we are gonna do, we are basically, this is our case third. So in that case, basically we found, let's make our tree little bit big. So if we have one also here, okay, so suppose we have to delete a node called 3. Okay, now in that case, first of all we have to check if we delete this node, we can make uh, what node will be replaced to our deleted node. So there is a this is the question, which node should be replaced by our deleted node, so that so that our BST will be valid. So how to replace a node so that our BST will be valid? So let's talk about a case. So if we know about in order in order traversal. Okay, so in order traversal we note that our root left side will be the all the left child and root right side will be all be the root right child. Okay, so if we take a root node, suppose 3 is our root node, 3 is our root node. Okay, so now we have to find left child. So in this case, if we found the pre-order, let's in order, let's let's find out what is the in order. In order is basically here 1 2 3 4 5 6 7. Okay, so as we can see, if our root node is this current root will be this. Okay, 3. Now all the present on the left side will be its left child and all the elements present on the right child till here up to here will be all the right child of this current root. Okay, simple. So from here we know that there are two child. Suppose we can say here, let's make a child name 4.4. Okay, suppose there is one more child 4.4. Okay, so what we are gonna do here, now we know that there are two child. So if we are taking left side of the array, we take maximum basically what we can say, maximum value of that child, of that left child array. Okay, if we are gonna traverse, if we're gonna do right, if we have to take right child, right element from the right sub array, we have to take the lowest element. Okay, so basically let me write it. If we have to take element from the left sub array, so basically this is a sub array and this is our right sub array. So let me make it left sub array and this is our right sub array. So left sub array. So for replacement we have to take maximum element. If we are going with right sub array, we have to take minimum element from that sub array. Okay, so this is simple. So now for this test case we are taking right sub array element. So what is the what we can say, what is the minimum element from the right sub array? It is 4. So basically we replace our this node with 4, basically 4, and this node become 4.4. Okay, simple. Let's try to code this all the 3 points. So let's try to code. Let me open. So yeah, first of all, in this part we have to make an function to solve this. So basically we are making a function known as, what we can say, let's make a function name as, we can, let's not make a function. If we need, we gonna simply do in the midway. First of all we have to check whether our root base condition, basically we have to check it whether our root is null or not. If our root is null, we basically return root, simple. And at the end, root also. Okay, so this is our structure, this is our base case, simple. Let me increase the font size a little bit more. Yep. So if our root node is null, we basically return root. Okay, now we have to find where our key is present in the binary array. So as we know that this is a binary tree, we search a node in basically dividing it two parts. Okay, so first of all let's search if our key is smaller than root value, then we will traverse to the left side of the tree. Okay, so how to traverse? Basically we go uh, what we can say, root left will be equal to delete node root left side along with this grid. Okay, simple. If is greater than its root value, then we will travel to the right side of the tree, which is basically root right. So for that we have to traverse to the right side of the tree, right, sorry for the mistake, right along with key. Okay, so this is our, basically we have to find key. So if our key, basically if we got our key, so now the three step which we wanna do here. So first of all we have to check whether our whether our root contains any child or not. For that, if our root left is equal to null, simple, and root right, right is equal to null. So if our root left and right both are null, then we basically return null. Okay, simple. Else in the this is our case one. Basically, we can say case one. The root node is a leaf node. Okay, let's talk about another case. If one of the root node and one of the root left or right will be null, one of them will be null. So we put here, let me correct it, or. So for or we have to basically put here not value, so that we can get only one answer when both of. So that's, so we have to find out whether our root left is equal to null. If our root left is equal to null, then we put, just a second, if we found root left will be null, if we found root left will be null, then we return this part, or let me do some. Here, return if left is null, then we have to return basically put here null left side. Okay, simple. Else return root right, right, est right. Okay, so this is our second case. So let's put it here. Case 2, one of the child is null. Okay, so let's talk about third case. Now in third case, first of all we have to make temporary node for switching the value. Let's make 3 node. 3 node, basically this is the structure. Yep, 3 node. This is on a temp, so we are putting left maximum child. So root left, root left left. So for if we are traversing root left, we have to take maximum value, as we can see in whiteboard. Let me show it again. Yep, so if we are traversing left side of the array, let me draw it again. Yep, as you can see, if we are traversing left sub array, then we have to take maximum element. If we are traversing right side, then we have to take minimum element. Okay, simple. For that, let me go to again code part. So we have to traverse till we got right, basically temporary right null. So temporary, let me correct it, temporary right, 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 till it is not equal to null, we put temp is equal to temp right. Simple. This is a simple for loop for getting the maximum value. So then after getting a maximum value, we put root value will be equal to temp value, which is basically the max value from the left side, left sub array. Okay, simple. So after putting, again we have to basically we have to make that node um, null, or again we have to delete that node. For that we use recursive for. So again we delete node root root left left along with the temp file. Okay, simple. It's simple. Let's try to run this code. It's giving me wrong answer, so where would I do something wrong? So let's debug it. So first of all, we have to return null, return root. If we found root is null, okay. So if key is smaller than root value, then we have to traverse to the left side. So yep, we are traversing left side for root right. So if key value is greater than, we traverse left right side of the array. Again we come to this part. We have to check whether, let me run this code, whether it is running or not. Nope. If root is equal to null, then root right. If it will be equal, if we found that root left will be null, then we have to return null for that part. So where do I have done mistake? We are passing here root right. Okay, in case of we find element, we basically check our root whether it is first of all we have to check our child whether the root node is leaf node or not. So in case of its leaf node, we basically returns null. Okay, so in case one of the child is, so this if, yeah, in this part we have to put else if. Okay, so let's try to run this code. Let's use test case, then run it again. Yep, it's give me right answer. Let's try to take all the three cases. Suppose in this tree we have to delete our leaf node. So let's take 7. So is it deleting or not? Yep, it is deleting. So again we take second case, whether one of a child is not present. Okay, so in that case, is it deleting or not? Nope, its output will be, yep. So we have to put here not equal to. If our root is, then we have to return the left side. Okay, yep, it is correct. And let's take a case where we have to put 3, and yep, it is the base case basically. So let's try to submit it. Let's try to submit it and check it again. Yep, it is submitted. So thank you.